Is this the most powerful domestic battery installation on the market? Today, we're going to find out. Let me show you where it's going to be installed. We're at a huge residential property in London where we've installed 74 solar panels across 2 roofs, but this is the cherry on the cake because the inverter and batteries are going to go here. And we've got a 25 kilowatt inverter, 3-phase, with 48 kilowatt hours of battery storage, all going in one stack. And this is the product. This is the SigenStor product from a company called Sigenergy. It's the first one we've ever installed, but we're looking to install much more because this product has a few unique features that we cannot find anywhere else on the market. Let's get it downstairs and we'll start unboxing. So on the floor there is the gateway. This is the inverter. I think these are the side panels. This is the communication module, and there's a CT sensor pack as well, although I don't think we need that because we've got the gateway. And then these are the batteries. So we've got 6 boxes, and that is 8 kilowatt hour battery modules. Oh, they are pretty heavy actually. That's definitely going to be a 2-man lift. Two down, 4 to go. So, a bit of feedback to Sigenergy, even though they're sponsoring this video. That is a pathetic handle, not good enough for lifting such a heavy battery, so definitely need a little bit of improvement on the packaging. Whew. Right, 1, 2, 3. And we did it. 800 kilos down a flight of stairs. I wouldn't recommend it. So let's get this stuff unboxed. First, the gateway. This is unique in that it is a 3-phase whole house backup system. Now, as you know, we fit lots of different battery storage products. Tesla and Sigenergy are the only ones that we do that have whole house backup, but they only work with 1 phase. This is the first system we've ever installed that will back up all 3 phases of a property, and that makes it perfect for big houses like this that have got 3-phase supplies, or even businesses that have got 3-phase supplies. But then this takes it to another level because the Tesla Powerwall and the Sigenergy all-in-one, for example, they're EPS, not UPS. So that means that they will switch over to backup mode, but it takes a few milliseconds and they might skip like half a sine wave or something. So you can't guarantee that the supply will be uninterrupted. Electronic devices might trip out and reset, for example. This is what they call UPS, uninterrupted power supply, which means that it switches over within, wait for it, 0 milliseconds and keeps the power running completely uninterrupted. You know those little silica gel packs that you get to keep stuff dry? Well, this takes it to the next level. This is like, this is like the size of an ice pack or something. It's huge, but that's the job. It looks like it's made by Superdry. I didn't know that they made these. I thought they only made clothes. So we're going to talk about the gateway in a bit. That's going over on the other side of the plant room. The mains power will be going through it. This is kind of the hub that the batteries are wired back to. But first what we want to do is get the batteries and the inverter mounted on the wall, and the batteries are here and the inverter's there. These are the battery modules. They are 8 kilowatt hour modules, and you can stack up to 6 of them for a total stack of 48 kilowatt hours, which is huge. And you can do that with a 3-phase or a single-phase system. In single-phase, I think the biggest inverter that they do is 6 kilowatt, so still pretty decent. 3-phase, this is the biggest inverter that they do, 25 kilowatt, and that's what we're installing today. Bolts to fix the thing back to the wall, which is quite important because they are very heavy, as we've seen. These are the little screws to screw the side plates and wall brackets onto. These go in and then you use those to fix it back to the wall. Those are like the wall brackets to mount it onto the wall, and then you've got these additional ones that go on the sides. So it's really solidly fixed to the wall, which is important. And then here you've got the little side plates, which are basically the finishing touch to go on either side of the battery module. So this is the actual battery module itself, and what's clever about it that makes it stackable is this. You've got this sort of plug module, basically. The top of one module plugs into the bottom of the other module, and that's what makes them completely stackable. So the question is, how do we actually lift the battery module out of the box? There doesn't seem to be any handles on the battery module itself. So this is the base for the batteries, which is quite important. If you're installing more than 3, I think, in a stack, you can't only rely on the wall mount, you need a ground mount or floor mount base as well, which is what we're doing. And here it's got the wall template, which is important for mounting it. It seems like a simple piece of cardboard, but it's actually really important for getting it on the wall. Aha, here we go. I knew there would be something clever. So these are handles. So those are what we need to lift the battery safely, which is great. And this is the floor base. Now let's talk about the elephant in the room, where this battery is going, right? So we're in a basement below a pool house. It's remote from the main house, so from a fire safety point of view, that's good. There is a fire exit here. It does go through the pool house, but you know, that is what it is. There is a fire alarm system in here, so that's good. However, this blue floor, you might be thinking, why is the floor blue, Jordan? That is a good question. So look behind me, all of this water equipment, right? And literally the other side of that wall there is the swimming pool, okay? So if I were to drill a hole through here, all of the water from the swimming pool would come flooding into this room. But there's a heck of a lot of electrical equipment in here, including the meter, the main incoming supply, the main MCCB panel board. So this is a plant room, it's designed to have plant. But there is a small chance that something could leak and water could get in here. So they've got a sump pump system. What that is this little thing here detects if there's water in this tray. There's a whole BMS system running this house. So it will read what's going on, all the temperatures and things like that. The sump pump over there, if there's any water in this area, will pump it out. And now we're gonna have backup power, so even if there's a power cut and it floods, the sump pump will still work. But there's a small chance that all of that still could go wrong, and I'm not really comfortable fitting the base of the batteries directly on this floor. Because if you see here, they have had a leak in the past, and the water's got up to about here, and it has started to corrode the bottom of these uni-struts a little bit. So what we're going to do, and we've spoken to the customer about this, is we're going to put a couple of slabs underneath the base of the battery to just raise it slightly out of the potential wet zone, and then we'll build the stack up from there. That means that even in the very unusual chance that some water gets into here, the base of the battery is not going to get wet. So you might be wondering, why have they sent these little metal discs? And I wondered that too. The answer is, these are actually shims. So the idea is, this base has very nicely got a level on it, right, in the middle. And I can see that, to be honest, it's pretty much bang on, which is great. But if it wasn't, I could put these little metal shims underneath just to bring it up to the right level. And you've got different thickness of shims in order to chamfer it across to get it just the right level before you then start to build it all up. Nice little touch. Sige. So we've got 6 concrete blocks basically to lift this off the floor. It is bang on level, which is fantastic, and we lifted the metal base above the edge of this drip basin essentially, so it means that there's no chance of water actually getting to the bottom of the battery now. So now it's time to stack those modules. These handles are really clever because they literally hook over these little end bits like that, and then you just pop this down like so, and that now will not fall out. So that is safe for 2 people to lift and drop into place. Yeah, so this template is one of the things that makes it super quick and easy to install. And what you need to do is you need to unflod. Make sure you're unflod. Pop that in there like that. Make sure you get the base the right way round too, because that was a mistake I made at the start. And basically it should just slot in like that, right? So you unflod that bit, you unflod that bit there. And then it lines up on the wall and it gives you the exact locations for the battery pack screws, which are here, and the inverter screws are there. So when we get to the top of the battery stack, we're going to do a hole there. But for these ones, we do the pack stacks basically, which are on the outside. And it's only 2 screws for each battery pack. So let's go. So now that we've fixed the base down to the floor, which is important, what we are going to do next is start stacking the batteries. And that is supposed to be the easy and quick part. So we're going to time it and see how long it takes. 1, 2, 3, Let's go. Okay, so the 6 batteries are stacked. The reason we didn't film putting the last 2 modules on is because we had to use some special lifting gear, AKA our cameraman. But to be honest, that is a high stack, so next time I would probably use some kind of special lifting gear to actually get it up. That was not easy. But the cherry on the cake now is the inverter. Let's put that on the top. That is a big stack of batteries. So that was 12 minutes to stack everything up, which is pretty darn fast. And no connecting cables needed, which is awesome. So now one last thing, we need to connect all the battery modules together with little connecting plates. That's just a mechanical connection to hold them together. And then 2 screws at the top to hold the whole thing back to the wall. So they make it very easy. This is for the right-hand side. And it just goes in there like that. And then it's got 3 screws to screw it in. And that just holds the 2 battery modules together. So this is where the gateway's going, on the wall there. And what we've got to do is get the tails out of this main switch. They currently go into this panel board. We've got to reroute them now through the gateway. So they'll go into the gateway and then out of the gateway into the panel board. And that means the gateway is controlling the whole system, monitoring how much power the property is using and instantaneously switching over to battery power if there's a power outage. That is a 25mm tail with a lug to go onto that neutral terminal. Under here, I thought we might need lugs too for this MCCB, but it actually looks like they've just wired them in, and I think that's how it's designed. It's got like some washers, but we're gonna need an Allen key and stuff to get in there and torque that up properly. This is gonna go into the gateway. This is the armoured cable that feeds the battery. And because we've earthed the armouring at the other end, because we've got an earth core within this, we don't need to earth it at both ends. So we're just going to put it in a stuffing gland at this side. But what I want to do is just get the gateway open, have a little look inside it. So this is an absolute beast. This is the incoming circuit breaker, 100 amp breaker, 3-phase and neutral. That's where the grid feed is going to go into. So from the main isolator into here. Then it all goes through these contactors and bus bar systems. The smart port is actually for if you want to connect like a diesel generator or something and you can have a second feed. The backup side is that what's going to feed back out into our MCCB panel to run the whole property. We'll just use inverter 1, that's a 50 amp circuit breaker. And the nice thing is it's got a built-in AC surge protection device as well, and the inverter does have a DC surge protection device. And all of these glands are labelled, so our grid connection can go in there. However, I'm bringing tails into this. Don't know whether I should use a special tails gland if possible. They've actually given us some slightly shorter M8 expansion bolts, so we can get that marked up and fixed onto the wall. So what I'm aiming for with this gateway is to have it basically a 10 centimetre gap on the left hand side and a 10 centimetre gap on the top, but the gap on the side is slightly different to the gap on the top. So I'm going to make it 180mm from the side bracket and 220 from the top. So one of the things I love about the Hilti drills is these vacuums that are self-powered and basically mean you've got dustless drilling. So it just makes it a lot safer and neater to drill holes with this. And it just retracts like that. You can slide it up or down depending on what depth you want. That's pretty much bang on what we need. So these bolts, you need to just get them tight so that the anchor is properly embedded in the wall. And then you can actually undo them, pop them out, put the mounting bracket in, and then refix them. So now that the bracket's mounted, we can mount the gateway on the wall. So these wall brackets, every couple of modules, you need to fix the batteries back, whatever's reasonable according to how many you're stacking and how solid your wall is, etc. There's 2 different lengths of these brackets. long and short. The long ones go on the left-hand side and the short ones go on the right-hand side. I think you can kind of mix and match depending on how it's laid out, but you have to space the battery stack about 5 centimeters off the wall, otherwise these will not match up. That's really important, and to be honest, we made that mistake. We put it right against the wall to start with, and we couldn't fit these in, so we've had to unstack everything, redo the brackets, and then stack it all again, which was a bit of a pain, but you live and learn. So we get to the inverter, and the screws to fix the inverter down are in slightly different position. So back to our cardboard template, and we can see you've got INV here. The internal ones are for the inverter, basically. So we've got the brackets on for the inverter, and these things are supplied with it to actually put a padlock through there so that it's kind of essentially locked on, and then people can't, I guess it's to stop people stealing it or something. Obviously down here there's no way that anyone's going to get in and steal this, so we're going to leave these off, but interesting to know what they're for. So now that we've got it up, what we're doing is connecting the AC cable with this HO7 flex cable from the AC isolator. It's going to go along the cable tray and into the side of the inverter here. Then we've got our DC string cables that are going to go in. We're just waiting for the final panels to go on before we can do that though. And then we're going to run our comms cables in and connect those up. So this is a 10 core HO7, so it's fine stranded flex in there. It's very, very nice and flexible. We use that in general for running cables from AC isolators to devices. So we're putting these lugs on the end of the wires to fit into the terminals on the AC side of the inverter. What we've got to do is use this crimping tool to make a nice sound connection. Right, so here in the plant room, me and Lee are busy buttoning up this gateway. It's nearly 9 PM now. We just want to get all the cables into there and terminated so that tomorrow we've just got to connect into the main MCCB panel basically and do quite a quick changeover. The joys of working a late shift. So it's day 5 on this project. Lee and I finished at 10:30 last night. The Taco Bell and some nice hot chai from our customer kept us going till late into the night, but we got this all prepped. All of the tails and all of the cables in general are wired into here. So you've got the tails that go in from the grid, the tails that go out to the board for the backup. We've got the inverter circuit, and we've got the 2 data cables, one that goes to the inverter, one that goes to the BMS. So in here, it's basically wired up. We've just got a couple of earth wires to put in here as well, but that will be from the main earthing point here in, and then out to the main earth terminal there. In 1 hour from now, we're going to do the shutdown, 10 AM. So I'm just going to clip these tails to the wall so that they're secured. Then I'm going to take the tails across and into this trunking here, and then we're kind of ready to do the changeover. We're about the moment of the power shutdown now. We've got about an hour where we can basically keep the power off to get all these tails wired in, ready for the gateway to go live. And I've said to him that we'll test these breakers while we're doing it, because it's a rare opportunity. It says press to trip, we trip. There you go, it goes off. Same with the plant room. There we go, that's this room. Oh, and that one looks like it's broken. You see, this is why it's good we check. There's a piece missing there. First floor DB, sort of like access to metal inside there. That goes off, and that should be all the power in this board off. However, we want it to be completely dead in there and safe to work, so we're going to turn this main isolator here off. So with 3-phase, there's a lot of different combinations that you need to test. Let me know how many combinations there are in the comments. L1, L2, L3 to earth and neutral to earth. Then we do neutral to L1, L2, L3, L1 to L3, L2 to L3, and then L1 to L2. All good, but now we need to test our tester again, just to make sure that the tester is safe and working properly, which it is. So we now prove dead, and normally you would lock this out so that nobody can turn it back on while you're working on it, but as I am literally working here, I'm not going anywhere, I'm not going to lock it out. You know what I'm going to say. Neat or not neat? What do you think? Not bad, not bad. It's fairly spacious as boards go. Now, you might be wondering, why have they got such a big panel board for a house? Because normally you install these type of breakers when you've got a really high prospective fault current and that normal breakers are basically not strong enough. These breakers are rated to like 85 kA or 45 kA 3-phase. So you might think it's a bit over the top, but the reason is they've got some long runs with big chunky cables that normal breakers just wouldn't be able to take those size cables. 25mm 3-core, for example. For that reason, they've used a panel board to distribute everything out. It gives you a nice little space to work and connect all your sub-circuits. We've got everything wired in. I'm just going to do a couple of tests before we turn the power fully back on for the client. Right, moment of truth. So power on to our gateway. So this is our grid breaker. Boom, contactor kicks in. Power our outgoing. Turn this on. That will then send power to our main panel. We should also turn the circuit surge protector on. And now we can do a polarity test here. There we go. Yeah, that's all good. So, main breaker, and then we'll go in reverse order. So that probably is the house. Fire alarm, first floor dB, garage, plant room, pond. There we go, power on. So gateway's all wired up and livened up. House power is back on. All of our AC testing is done. So now we've just got a few more panels to get on the roof, one final string to wire up, and then we can start livening the battery and inverter and commissioning everything. So this is it, the moment we've been waiting for, commissioning time. Now I have the privilege of turning the system on, and we always start with the DC side. I'm following the instructions here just to be sure, right? So we're going to turn our strings on here, boom, and then we're going to turn our DC switch on. Magic! Yay! We have internet. Wow! I like this so far. If we scan it again, it should actually say that it's connected. Yeah, there we go, we've got the system. Fantastic. So it's a residential system location. Wow, you literally press and it pins your location. You don't even need to type it in. Total panel capacity, kilowatt peak. 445 times 74, right? 32.93, that is a beast of a system. Okay, download and install firmware. Let's see how long this takes. This is the bit that is scary. Oh look, 24 seconds remaining. Yes, I love it. Usually they take like 2 hours, by the way. We now click that we confirm all devices have been added to the system. Click next, swearing into life. Okay, so we've done all of our checks. It says system check has been completed. And that was very easy. Ethernet is currently connected. So then we click next, and then it's giving us a list of all the basic info. Yeah, we're generating 6.5 kilowatts of solar, look at that. And the home is using 4.1. Wow, I love it, it looks so cool. That genuinely was the easiest commissioning that I've ever done. So congratulations, you've won the Artisan Electrics Commissioning Award. Can't believe it was that easy. That's so cool. The ultimate test of any battery system with backup power is when you turn the main switch off and everything runs purely off that battery storage system. That's what we're gonna do now. The studio light that's shining on me right now is plugged into a socket in this basement. You've also got the control panel. So in theory, we turn this switch off, we should not notice any difference. You ready? 1, 2, 3. Amazing, look at that. UPS, instantaneous backup power for the entire house. All of those circuits are now running off that battery in the corner. How cool is that? So we've been running for about 5-10 minutes on pure solar. Actually, the battery is still charging because the house was using less power than the solar was generating. And we're still in off-grid mode now. We're going to flick back to on-grid mode. And what we should hear is after a few seconds or minutes, the contactor switches in and it switches us back over. It doesn't do that instantaneously for the reason that sometimes you have a flicker on the grid where it flicks on and off again, and you don't want it to destabilize things. So it will wait until it's got a reliable grid connection before clicking in. Let's see if I'm right. So we should hear a contactor clunk in here in a minute. There we go, we're back on grid. At the start of this video, I asked the question, is this the most powerful battery storage system we have ever installed? And the answer is yes. This is an absolute behemoth. But the question is, will I be installing more of them? Now, as you know, this video is sponsored by Sigenergy, but I have to say that genuinely this is the most impressive battery storage system I've fitted to date. I also think it looks amazing. It was pretty easy to install, even though we had a few teething issues because it's our first one. Amazingly quick to commission. Like the best commissioning experience I've ever had as an installer for a battery storage system by far. It literally took 10 minutes and about 5 of that was doing the firmware update. That I love. But not only that, it has features that no other battery storage system out there on the market now has. Now, is it the cheapest? No. But if you have a big property like this with 3 phases and you want a whole house backup, there's nothing out there that even touches what this system can do right now. So I'm definitely going to be designing more systems like this for our clients going forward, because this has been a pleasure to install. I'm pretty blown away by this product, and that is a rare thing for me. So I hope you've enjoyed watching this video. If you have, make sure you like and subscribe, because we've put out loads of videos about battery storage, solar and other renewable energy technologies and actually installing them in the real world. And if you'd like to settle in and watch another video, there'll be 2 videos up here on the screen that YouTube thinks you'll enjoy. So why not settle back and enjoy those?